Alrighty. So apparently the live stream is now working, which is good. So we'll be able to kick off our testing session today. Just kind of before we dive fully into it, in typical DevNQ fashion, we'd like to thank our sponsors for this event, of which we actually have two this time. So we've got JCU, who's catering for tonight, as well as providing the venue. And we have JESI, who's also assisted me with providing some time, getting this together, and basically allowing me to model this talk from the practices that we do at work. So everything that is listed in this following presentation, plus extra stuff, is what I pretty much do day to day in the land of software development. So that's cool. Please no flash photography. Developers are afraid of the light. But in all seriousness, if you actually want the slides, they are publicly available, so you won't have to use their phone to trying to capture what's on the screen. Likewise, all of the example code and a full working project is up on GitHub, so you can save yourself that bit of pain. Yes, so testing in a global SaaS product. In this room, how many of you would be students? Hands, we've got, what, maybe 10, 12? Any developers who are actually paid developers? Used to be, yeah, so maybe 6, 7. Hobby developers, so you're just doing it for your fun of it. Couple, excellent. Any non-developers? Yeah, that's the kind of thing we want. Extra people. So I guess for the developers in the room, and even the non-developers, is there something wrong with the slide that I have up at the moment? Yes, Andre?
Are developers really afraid of the light?
That is an excellent question. It's kind of a stereotype that we apply to developers, and it kind of plays on this entire presentation. It's an assumption. It's a stereotype that's been passed on by everybody, but we just assume it to be true. So in the case of testing software, you should always test your assumptions. First rule of testing. So let's dive into it. So testing of a global SaaS product, these are basically going to be stepping stones and layers of things that I will cover, starting from foundational things, which JCU, I believe, teaches in a couple of subjects, to the extension on that, which we do day to day. So when you're coming into the industry as a professional developer, the base layer is what we expect developers to be able to do, which is just basic unit testing, and then we provide a whole bunch of extra layers on top of that, which extends it further. Which hopefully I'll be able to touch on everything you need tonight. So can anyone tell me why we test?
Can I ask questions during the thing?
If you want to, Andre.
Excellent. First question.
Yes.
What's a SaaS?
SaaS is a software as a service. So basically it's a digital product that a company will provide for clients to use where they don't have to maintain hosting. They pretty much pay for the privilege of using your software but not maintaining it. Cool? Yes. Lindsay. I think I've been around long enough that I probably don't need to. Okay. Would everyone like to know who I am? Yeah. All right, so I'm Alex. I was once a student for a very long time. I have since moved on into the industry, but I pretty much picked up programming from grade 7 or grade 8, discovering programming books and kind of just playing around with myself and helping my dad in sporting association with little programs. So I did that for several years until I decided to stop doing civil engineering at uni and switch to IT, which has become my primary focus. And I've always wanted to be a developer. So I've always wanted to actually write code for organizations, specifically in the business sector as opposed to, say, game development. I had that opportunity to pretty much make development my full-time career and actually get paid for doing it at JESI in around 2017, I want to say. So I've been a professional developer for the last couple of years. But a lot of this practice I learnt before going to JESI with some extra stuff afterwards. And it's really something that I'm passionate about in terms of like improving my own craft. So this is stuff that I will do to make myself a better developer, but also to allow like working with other developers seamlessly. That's about it. Sweet. Sorry, just heard the aircon go off. We'll see if that works. Alrighty, so can anyone tell me why we test as software developers? Or any ideas? Like, yes, Jodo.
So things don't break?
So things don't break, absolutely. Anyone else?
So the customer's getting what they need?
Excellent one, definitely for a SaaS product. Any others? Debug is a really good one, but ideally we actually write tests to prevent debugging, because that saves us a bit of time. Yes, Andre?
I know where you sleep.
That's actually my big reason for writing tests. So for those who don't know, Andre is my superior in the software dev land. So if I actually do something wrong, that's on me, but he knows where I live. So that's really a fear motivator there. But other primary reasons that come to mind for me is quality. We're an Australian-based product, so we actually try to build, the Australian level of quality that we have. But in terms of software, you've also got reasons such as the performance. So you want to make sure that you're actually doing your things that you say you will quickly. You want to be able to reduce the amount of bugs that you have in your platform, but also stop regression. So that's things that have creeped into the product that are like a side effect of your recent feature development. Maybe you broke another part of your system. You kind of want to avoid that for customers. You want to have confidence in your code and other developers around you, so making sure that what they're writing is actually benefiting the platform and is implementing the feature you want. You want reliability to make sure your system is working for the clients. You want validation yourself that what the code you're writing is actually doing what you think it's doing, because sometimes it doesn't. And as Andre kindly mentioned there, is stress. This is not stress for the client, this is stress for me as a developer. So SaaS products are globally available, which means our clients have them for different demands. In the case of our JESI platform, we are a critical real-time system that could affect people's lives if incidents happen. So our system has to be pretty much operational 24/7. So if something really goes wrong, our stress levels go through the roof as we try and fix it as quickly as possible. So all of these procedures come around to try and lower our stress levels. Now there's a few things that I've heard in my time as a developer from various different people, whether they be students or other members in the industry, hobbyists. And I'll go through some of these points because you'll probably have some of these statements or have heard of them. And that is, to begin with, testing is too hard, I'll consider it later. Has anyone actually heard this? Yep. So there'll be a lot of members in the industry who have heard this before. My counter arguments to this is pretty much testing will actually improve your algorithm and implementation. It promotes clean code because if you can't test your own code, you have issues already, so it forces you to do a restructure. It'll help push any third-party dependencies to the edge of your application, which means if they have issues in the future and you want to sort them out, it'll be an easier job for you. Tests are also developer documentation. Tests are much easier for a developer to come in to understand how it works than it is trying to piece API documentation together, especially if you have the source code. And another point that I keep coming back to is confidence. So having the confidence as that developer that your program is doing what you're paid to make it do. I can run the test manually before I deploy. No, you can't. This can happen when you're starting a project and maybe a uni assignment. You can run through a couple of basic business scenarios initially. But as the software grows and you get more developers on, you could have thousands upon hundreds of thousands of tests in your software base. You cannot run all of those scenarios manually yourself. They are very time consuming. You will miss edge cases. And in the case of SaaS products with web environments, you cannot test every single browser configuration that a user has. If someone wants to pop into your site using Puffin browser, I don't even know how to get Puffin browser, so that could be an interesting debug. Tests are not production code, it doesn't affect my users. Half of this is true. Tests are not production code, but it does affect your users, because if your application is not doing what it wants, or what you programmed it to do, then you introduce bugs, your application is not usable, you introduce regressions, and you're breaking the promise that you have to your clients. In pretty much of this, I consider the testing to be part of the actual feature. If you're developing something new, the tests are part of it. They're part of the estimate. They're there to prove that it actually works. And ultimately, they're there to make sure your users continue paying you, because that's how you get your money. Very crucial thing as a professional developer. So who can tell me when we should test?
After it breaks.
You should definitely add more tests after it breaks. Anyone?
Before deploying a new feature.
Should be testing long before we do that, but yes, definitely before we deploy a new feature. I'm going to say it depends. And it depends because every situation is different. Everything that you're writing as a developer varies. You could be writing a SaaS product, you could be writing an embedded system, you could be writing a CLI tool, an automation script. We cover all our bases in software development. So I would pretty much say, if you're writing something, where you are not the target user. So you are giving it to someone else, there is a client, you're making it open source, you test it. Because ultimately what happens if something breaks, they come back to you to try and figure out why it broke. Make your life easy, test if you give it to other people.
If they've paid money, they probably want blood.
Not even if they paid money, even if they're your superior. So, software development in terms of unit testing is based on first principles. So this is where we're going to start looking into some code. We're going to start looking into some practices. There will be a quiz on this towards the end. I expect everyone to be able to answer this before you can have food. Maybe. So the first principles, fast. Your test should run as quickly as possible, and ideally in milliseconds. This is both to assist in a rapid development feedback cycle, but also because, as I mentioned before, you're going to have thousands to 100,000s of these tests. If they take a minute each, you're never going to be able to run all of the tests in your entire platform, which means as a developer, you'll become lazy and basically skip running those tests. So you want something that's really quick, gives you the answer you want, only tests the case you want, and just gets out there. Your tests should be isolated, which means that they should be order independent. They shouldn't depend on any other tests who have run before. They should arrange all of their data in their own setup if they need to. So that's if you need a pre-populated database, that should be part of the test setup. They only invoke what parts of your application they need to invoke. And they only assert on anything that needs to be asserted. So there's no point writing a unit test for a really low layer that's trying to test something very high, because they're completely isolated things. So you want to try and make them as small as possible, but only assert what needs to be asserted.
Alex,
Yes.
so because just not being a developer,
Yes.
are you able to clarify what you mean by assert?
Yep, so assert is pretty much a scenario where I say, I expect true to be false. That is an assertion statement, right? So obviously that is a false assertion statement, but they're little statements where we will extract what the application gives us and we will expect a value to match.
And that can be like a string?
Can be a string, can be a boolean, can be a data type. It could be I created something in the database, I set a HTTP request. The possibilities are endless. It just depends on your scenario.
Yep. Okay, cool, thank you.
No worries. Next, your test should be repeatable. They should yield the same result every single time they run, and they should not be dependent or influenced by external factors. So a really nice example of this is if you're doing any kind of date-time testing and your systems run in Brisbane, but your servers run in UTC, the tests work in UTC, they don't work in Brisbane, that test is not repeatable. So you need to come up with a way of running those tests regardless of where you are. The test should be self-validating, which means they tell me that they've failed. You shouldn't have to look through and try and identify going, did this test fail, did this test fail? They should tell me right at the end going, this many failed, and in the case of automated testing, they should actually give you a separate error code to indicate a failure. That's very crucial, because if your tests are failing and you don't know, you're deploying broken code. Finally, the test should be thorough. And in this case, I'll fight Andre on a few different things here. But I believe that the test should cover all of the business rules that you can possibly test, because that's ultimately what you're building the product for in a SaaS environment. You should then look at testing all of your edge cases. So that's in terms of if I'm providing a positive number to some function that I've written, what happens if I give it a negative number? What happens if I give it infinity? What's it going to do? What happens if we give it no number in JavaScript? You also want to try and test those large or illegal values, so no number or string, anything like that. If there are known security or vulnerability issues, you also want to have tests for those, because you don't want to intentionally go, well, we knew this thing existed, but we haven't put any safeguard against it. This is your proof that you're protected against that vulnerability. And a statement that I prefer is you want to aim for 100% scenario coverage versus 100% code coverage. So code coverage to me is a vanity metric. It's used in development terms to say every line of code that you've written in the production system has a test that at least hits that line of code once. That doesn't prove that your application is actually doing what it should. It just proves that you can write a test case for it. The 100% scenario, on the other hand, combined with coverage, will allow you to identify code that is not even touched in the production system. Now, if code is not touched, you'll introduce code rot, and then what's the point of having that code there apart from confusing developers in the future who come across it and realize there's no tests on it. So it helps you identify what you can actually get rid of from your application. So let's look at a little bit of code here. So a very basic kind of class. A lot of the code examples I'll have here tonight are Java. There is also a few JavaScript, just because they're a very basic thing that at least we can understand. So in the case of this test, it accepts 2 integers, and it returns the sum of them. Do you still have stream there, Tristan? Because I've lost my preview display. Yeah? Okay, I'm going to roll on then. So down below we have the skeleton for a test case. What you'll notice here initially is we have a descriptive name. So this is something that helps developers understand what business scenario we're testing in this case. So it gives us a bit of context. The reason you want context in this case is some tests can get very lengthy. I'm talking 50, 60, 70 lines just for one test case. And it's very difficult to identify with all of the setup what that one little business rule is that's different to, say, the test underneath it. So these strings allow us to easily understand what we're testing in this scenario so that when we read the code, we understand. Now, unit tests follow 3 primary steps, and they're all beginning with A's, and this is part of the quiz. So the first step is arrange. This is where the test is setting up everything it needs to do in its environment for the test to run. So whether that be insert information into the database, construct a whole bunch of other objects, just everything it needs to do. We then have the act phase. Now this is where we're actually performing the invocation and capturing the result of the output. So pretty basic in that regard. Our final phase in unit testing is the assertion. So this is where we are expecting the result to equal what we have. So is everyone clear on that? Any questions on at least this bit? No?
Alex,
yes?
where did those numbers come from?
In the case of the 1 and 4, that's just basic math. I mean, that's my past, so I'm testing my own assertions. If I wanted to test this further, as I mentioned at the start, I would pull out a calculator myself and type the numbers in and be like, another program has told me it's 5. Sometimes we have to trust computers. So in this case, 5, I believe, is 1 plus 4. But if my test fails, I could have a problem.
But in terms of choosing a range of data, that would cover all the bases?
Yep. So
Rule to that?
the range of data that you're providing to your test cases should match your business scenario. Right? So if you're doing something financial, you're looking at probably float-based numbers and whole numbers and a large array of things. In the case of the JESI platform, we don't really have any basic number addition that I can think of. But if we were doing something related to us, it would be around a journey space. So we would have something that matches our business rules and edge cases that we could achieve in our system or we should achieve in our system. That's kind of where the numbers really come from. And depending on where you're testing, which I'll get in further, depends on where you'll pull these values from to test the scenario. This here is considered like the lowest layer of testing. Yep.
Are there other scenarios that we would add to that test?
Absolutely. So in this particular case, as I mentioned on the other thing, you're looking for your edge cases, your invalid data, your security exceptions, anything you can think of to throw at this that could potentially happen in your system or you want to safeguard against and verify it works. You would create any extra test cases. So if I wanted to test the addition of a negative number, I'd create a new test of add negative to positive. And I'd see what happens if I say add -1 to 3. What's the outcome of that? What happens, if I add 2 infinity numbers? We would build the test cases and see what our application does. If it throws exceptions, that's when we can put safeguards higher up to prevent those values actually coming in. Yep. So software testing is like onions. They stink? Yeah, no. They make you cry? No, except sometimes. You leave them in your code, they start growing little bug features? No, unfortunately. It's all about layers. Software testing is all about layers. So what I kind of described there in the first principles is the concepts of unit testing. So these are the bare minimum that you will reach in testing your application. So we're talking about the very low-level utility functions that pretty much accept arguments, return a result, but don't depend on anything else outside in the world. We then step that up further, and we actually have business logic testing. So this is where you'll come into a professional job, and you won't know the domain. Hopefully you'll know how to actually do the programming, and the senior developers will teach you the business logic. So these are the rules around the application and environment that we've created that we have to adhere to. So this is where we start adding some additional logic rather than generic, I expect 1 + 1 to equal 2. We then step up further and we look at end-to-end testing. So this is a scenario where we want to test that our entire application, built together before kind of production, actually works from the top of our stack right down to the bottom and back up. So we're testing additional things on top of just our business logic and how people access our system. So for those who don't know, SaaS architecture looks pretty similar to this as a very basic run-of-the-mill. You typically have client devices in the bottom corner there, and that's whether you do a mobile app or whether you do a web browser, the client controls that part at least. You then might have third-party services, which is external code providers who give you an API or something like that that you are integrating with to assist in providing value to your product. You then have your cloud infrastructure. That's where you have your persistent mechanisms, you have your servers, you have all your connections between it. All of this kind of stuff you can replicate locally, but that's pretty much how it's deployed in the cloud as a high level. Yes?
What's an example of a third-party service?
An example of a third-party service in the JESI world could be how we get time zone information for a latitude and longitude coordinate. So if we were to search this geospatial location right now, we would get something like Australia, Brisbane. If we were to search somewhere in the US, we'd get a US timestamp. So that's one example. Another example is our system sends SMS messages. We ourselves don't talk to the couriers and carriers and all that wonderful kind of stuff. We rely on other people who are specialized in that. So we interface with them to be able to send that part as part of our system. Excellent. This is the reality of SaaS. We have third-party services that suddenly become unavailable. We have browser, screen, user settings, which just altogether become a debugging nightmare for us. We can't handle all these scenarios. We have a cloud that is not so fluffy. You think it's fluffy, it's really not. It's always out to get you, i.e. all of a sudden you can just lose a database connection in your own cloud. Why did it happen? I don't know, someone at AWS pulled a cable, plugged it back in. Who knows? So all of this can go wrong in a production environment very quickly. But what you want to make sure is that your tests actually prove the resilience of your platform. Can you recover from these things? Are you able to accept that the third-party service is down? Do you have a fallover service? In the case of user browser settings, you might have a preferred browser like Chrome. And if a user is using something unique that is a very minute fraction of browser usage out there, maybe that's an okay scenario. And you just tell them, we're sorry, but you're a unique child. We can't really cater to the 0.1% of users. So these are all different in every scenario that you come across in every business. It just depends what you are willing to accept. In our case, we are not willing to accept a third party down, and we are not willing to accept just a database vanishing in our own infrastructure. So we have tests and scenarios that make sure this doesn't happen. Or if it does, it recovers very quickly. So in terms of the server stack, you might have something similar to this. You'd actually have your application written in multiple layers. At the top of the stack, you would have your communication layer. So that's where you would look at receiving network requests, whether they be HTTP, sockets, whatever it is, grabbing that information and payload transport. So it could be JSON, it could be XML, transforming that into something that your domain can understand and your language can interpret and extract data from. You then would pass that down to your business logic layer, which would then pass down to your data access layer, which would interface with your database and then return results back up. And your business logic might make multiple requests to your database and back, but ultimately that depends on what you're doing. Somewhere in your business logic layer, you might also have a request to a third-party service to do extra things for you. So with this in mind, let's get some questions. So let's assume that we've developed a middleware function that extracts an authorized user from a request context. So that is, someone has made a request to our server, there was a token, we decoded it, we know who they potentially are in our system, and for our function use, we want to extract that information. This function, however, will be called from a third-party library. So code that we haven't written, but code that we're extending that knows our code exists. How do we test this code in isolation? So all of a sudden we have calling from a domain that is not ours. We have the result returning to a domain that is not ours, but the actual getting this user out of the request is our code. So how do we test this code? Any ideas? Okay. The answer here is mocking. And Andre was really wanting to give me an answer there. So mocking here is a way of us abstracting our individual layer to be tested in isolation from external code, from basically every other scenario possible. We are able to test this without bottom layers, and we're able to mock results as well as what data is passed into our application. So this allows us to simulate what the third-party library is doing with our code. It allows us to simulate any kind of exception that may be thrown and how our code handles it. It allows us to spy on objects, which sounds covert, but it really enables us to make sure that the code that we've written is actually called, which you wouldn't think matters, but it actually does. And we're able to verify that it was called with the correct arguments that we expected. Now, mocking, as an example here, is the actual extractor. So this code is available on GitHub, as I mentioned. And as you can see, I pointed out kind of a few things here that is key in principle. So we have an object there that is passed and we create it. And you can see it's wrapped with mock. And I'll see if I can highlight here. Yeah. So there it is. So it's wrapped as a mock. Now this in Java is basically constructing an object that actually has no implementation, but allows us to orchestrate what it will do as we pass it in to our auth user extractor, which is our context here. So this when statement, when we get this attribute, then return this user. So this is us setting up the mocked environment. So all of this is part of the arrange. And we're pretty much saying on this mock that we just created, when whatever is using you calls get attribute, just return this value. I don't care what you do otherwise, just make sure you give this value. Like all other tests, we follow an act scenario where we actually perform the act. And then we have the assert. And just like the other one, we're asserting that whatever result we got was the result that we told the mock to give us, for one. But there's an extra step here, which is that verify. So we're actually verifying that our mock object was called with the attributes we expect. Now, this particular style of mocking in Java can be very useful when you're doing database requests. If you actually mock the data access layer for your business logic, you can verify that calls to the database only happen once. You can verify that things happen twice if you really want, or called with different arguments. And what that can really help you identify here is how efficient your trips to the database are and back. You know, if you're requesting information about a user in a single request and you're doing it 15 times, maybe you can restructure your code a little bit so you request that once and just hang on to it and give it to everything else that needs it. In web development land, humanized string representation of a date time is dependent on the user's browser and system settings. So this includes language. So how we represent, say, the epoch of 0 is different to Australia as Germany. How can we test this is working in our platform when this is a browser-controlled setting? Any idea? Exactly. We can mock this as well. So if you're using Node.js, you'll probably know that it's actually very difficult to get access to any kind of private function or anything that is not exported that your code depends on. And in this case, we have a function there called browser language, which literally just returns either the user's language setting or the system default setting from the web browser. If we want to set that up to mock it, we need to somehow change the return result of that browser language function to be what we want it to be. So with the help of Rewire, which is a Node module, it'll actually give us access to all of the private dependencies of a module, as well as all of the private functions, and allow us to change the result as we see fit, restore them, but also invoke those functions. So it allows us to do the testing on something that would otherwise be very difficult to test, and would pretty much be left to the user telling us that it doesn't work. So as you can see here, very similar to the Java, we have a mock invocation. We're telling it to return English Australia, and we have the assertion down the bottom, but the only difference we have here is we don't actually have a verify step. And that's because the way Rewire works is it's not actually a full mocking, we're just changing values. So it's actually changing the function reference itself rather than constructing a mock representation of it. Yes, exactly. So really useful in your module testing for Node.js, not so much in production code. Branching on next, we have the end-to-end testing. So this is the top of one of our stacks. So we want to test that all layers here are working together, including our business logic and our data access and our database. So this here is, as I mentioned, just making sure the layers work together. we want to make sure that the server and the stack is actually configured correctly. This is something that most tests don't do because you're talking about a single layer. But what if our server was talking to Postgres versus MySQL? What if we only handled JSON requests and not XML? So that's all part of your server configuration, which you want to test because that deploys as well. You also want to validate that content negotiation. So that's the reading and writing of JSON. Do you accept CSV? Do you allow exporting of CSV? Can users perform that operation on certain endpoints? Are method endpoints actually protected by authentication? i.e. if a user has permissions to invoke something, have you tested that they can invoke that with that permission and invoke it without that permission? You also want to test your transport protocols here. So if you have a HTTP server, in this particular scenario, you want to be making HTTP requests to your server. If you're using sockets, you want to be making socket requests. So this is where software can get a bit more complex in its testing, but this scenario gives you full confidence on your system. And this is where probably a lot of your business rules will be set up, as well as some of your lengthiest tests. So another wonderful question. In most SaaS systems, users are authenticated by tokens. Does everyone know what a token is? Excellent. They're usually granted by your server or some kind of third-party authentication service like Auth0, and they identify an actual user. So who can tell me what an end-to-end test would involve if we wanted to test that the token works? Yes?
Creating test data of a fake user with known credentials, because they're not real, who then goes and uses your login function to do the login, and then a token is generated and you check the validity of the token, and then you check that the token can be consumed, and then whatever thing they asked it to do actually gets done. There's obviously more testing that happens in that section, but that's further down the line.
That's exactly it. So in terms of arranged active cert, as Kate just mentioned there, we actually want to verify, as we set up here, the arrange. So let's actually create a user in our system. So generate some user, whether they be random or known credentials, post that to our server, and actually make sure that we have a response from that user. So i.e., we're creating a user, but it's not required for this test case apart from having a valid user. So we haven't mocked this scenario. We've actually created a user. We then actually go through and act by performing a HTTP request. So we're doing exactly what the browser would do, exactly what a third party would do integrating with our API. We post that data to our server as JSON. What happens? Who knows? That's where we do our assertion. So we're asserting a couple of things here for our server in HTTP. We're asserting that the response code we got back from the server is what we expect it to be. We're asserting that the token exists in the body of our response. And in this scenario, we're just asserting that the token is actually not empty. So the user got a token. They were able to log in. Our system said, that's great, here's a token. If you want to test the validity of that token, that's when we would go, okay, does my token work? So we would do the same setup, the same act, get a token, and the next test would actually be asking for maybe their profile. Will this token give me the profile of this user that I expect?
Alex, in that second step, would you redo this, or would you use this, like, getting the token twice for those two tests, or just once and then use it in the second one?
That is actually up to you as developer. As long as your tests perform in isolation. So if you can run them independently, maybe you have a lazy step that goes, I'll just create a user once and just reuse that token, then that can be a efficiency gain in running that test. But as long as it's clear that it's a shared setup in that scenario. We do that quite a bit where we will set up a few things that are commonly used through the whole test case as part of a class. But as long as the steps are clear in what they're doing, code reuse is highly promoted. Another form of testing that we actually do is integration testing. So as we mentioned in the SaaS product, we have a third-party API. This is something that's not in our control. This is usually a service that we're actually paying for, but we need to make sure that A, they're doing what they say they're doing, because you can't trust software in the spiky cloud. You also need to verify that your credentials to them are valid and that you know how to use their API. Sometimes they'll release a bug fix themselves because they're always pushing new code, and maybe something actually breaks in that. Who knows, right? Like, anything can happen. So how do we test this? Like, this is someone else's code.
Well, you're only interested in the response. So if you have a known response, then you need to test it for a known post that you get a known response.
Exactly. So you test what you know. So a wonderful scenario I have here is in our actual JESI platform, we facilitate two-way SMS messages between our users and our server. Now, as developers, this is something that is very difficult to test, but it's also a core feature of our platform. So we need to make sure that it actually works before every deploy. Unfortunately, all of our SMS providers are third-party. There's no point mocking this because it doesn't prove that our system can communicate outside. So we actually need to perform an SMS. But the catch here is we could send it, as you mentioned, we could hit our third-party providers and go, send this SMS. They give us a response code going, great. Question now is, how do we make sure the SMS was sent? And how do we make sure that we can reply to it and the server gets that message? So now we've got more factors outside, but are crucial to our platform. Any ideas on how we would achieve this?
Would you just set up like an external device that operates through the different SMS providers and then, make sure that you're actually receiving it on those devices?
It's a lot of different devices.
That potentially could be a lot of different devices, but you're on the right track there. So rather than maybe a device per provider, maybe you just have one device that accepts stuff. And that's exactly what we actually did. So in the JESI platform, as part of our integration test suite, we invoke all of our third-party SMS providers. They all send my phone an actual SMS, which is fantastic, I can tell you. I do get free SMSs. My phone is actually configured as an Android with all the wonderful automation tools we have to respond to these SMSs in a certain manner. So our system might send an SMS with a UTC timestamp. I'll actually reply with that same timestamp. So extract that, send it back to whatever number sent it to me, and then depending how that provider forwards it to our system is how we verify that that actually works. So I'm testing timestamp the server sent me is the timestamp I'm replying to. And that tests that at least my phone can send and receive messages, which in theory, other carriers should send and receive messages. Unfortunately, in practice, that's spiky cloud again. Every country has different carrier settings, different providers, all other challenges, but at least we have confidence that most of the scenarios work.
Can I just ask there, I'm sure I've done some stuff where you can actually make an API call to verify that it has been sent, or you can get a response to say, I have sent it.
Yes.
Some of the providers.
Yes, that is very much provider dependent, and we rely on that, and they're known as the delivery receipts.
Yes.
Delivery receipts can still be...
And they're costly too.
They're costly, but they can also be a bit iffy in SMSs. A delivery is just that provider gave it to the carrier.
Gotcha.
There's not always a full confirmation that the device has received it. So if my phone is off, I can't reply to that. Yep. So that all comes down to what third parties you're using, what services are available. If they have that mechanism and you can trust it, then I would definitely go that route. But sometimes you have to go a little bit further than you anticipate. So at this point, I'd like to introduce everyone here to Project Orion. So as I mentioned at the start, there is a whole code base available on GitHub under this URL here. Also, this is where the presentation slides exist. This code base is set up in the style of a SaaS product. So there is a JavaScript web front end. There is a Java back end. They actually talk to a database. They communicate over REST. There's basic authentication. And it gives you examples of mocking, of unit testing, of front-end development testing, and of something that's coming up as well. So this is a very good learning resource for anyone who's interested in how this is set up and how you would progress yourself. And I do highly recommend checking it out. But that scenario I just mentioned. So we have this setup. We have a SaaS product. We have a front end that is now detached. It could be written in a different language. It could be a mobile app to the server, which is headless, hosted elsewhere. You don't really have an interface on top of it. How do we verify that works? We're now in two separate domains. We've got a browser domain, a server domain. What do we do? How do we make sure our actual projects talk together? Any ideas? What's this mean?
You type it in, right? You actually go
Oh.
And test it manually.
Sure, let's do that. I'm going to try this because I don't have a screen here. Yeah, so I have it running at the moment. I'm going to try and log in here. So I'm just going to test this manually. So I type in some password things. I get a pop-up that's kind of annoying. I can barely read the screen. Let's create a new event. So let's call it, I don't know, something. Let's put it in the future a little bit. Let's give it a description. I'm speaking here, cool. Submit it, and there's probably, oh yeah, there's a something. So, okay, system works. We done? It works. But like that's one business rule in this example system, right? So this is something where that is very time consuming. But that is the ultimate level of testing that you really want in a SaaS product. This is proving that your front end and API and everything that you have in between it is working as you expect it is working. As developers, we can't be happy with just manually typing things in. We need a way to automate this. And automating in this, if I can get my slide right back, is known as many different terms, and they all have different outcomes. It's either known as functional testing, acceptance testing, or platform testing. The functional testing is just proving in the case of a SaaS product that what you say it can do, does. Your acceptance testing is typically provided to an actual client. So if you're being charged to develop a product that you're not hosting or maintaining, you'll have acceptance criteria to say the system can do this, the system can do that. So these acceptance tests are a way of automating that to prove that those outcomes are achievable. And your platform testing is a little bit more expansive, and these things would be constantly running to verify uptime, to verify things work in a production environment. So as a high-level overview, this is pretty much what functional testing gives us. We've given our individual little unit test, business logic layer, as well as end-to-end tests for one system. Then you got another server, then you got a front end. All of those have a similar stack that are tested in a similar way. So now our functional testing allows us to test the whole system together. And ideally, this would run on your local machine. Otherwise, you might even have to provision infrastructure to run these. So before I show you code, I'll give you an example of what this actually looks like, hopefully, if I can. Hang on. Yeah. So I have some basic code here, and I'm just going to run it, and hopefully it's set up here. So it started a browser, it's typing stuff in very quickly, it's creating, and it's done.
Just passed.
Yep, that's a good sign. Did anyone really want to see that again? Yeah, no? Well, I'm going to run it again because I really like these. So in our case of a SaaS product, we use automated browsers. So we're controlling what the browser is doing to mimic user behavior. This verifies that a user who is using our actual site can perform the actions that they need to get there in a path that we have developed. You know, they might stumble across an unknown path. Users are very good at that. But at least the path we intended for them to get on works. Now, this is very good for SaaS products because you could deploy a styling change that disables a button. Maybe a user's not able to click on that button. That will actually break the flow. So that's a good catch to go, that's styling. No, we can't have that. We need to figure something different. And these tests, like everything else, follow our 3 A's. If I can bring this slide back. Yeah. So we have an arrange, an act, and a set. And in this case, our arrange was the creating and registering of a new account, of which the credentials are faked. So I actually don't know what they are. That then actually logs in to that account after registration. It then creates a new event. And then it goes to the event listing page as part of the assert to go, can I see that event? So that one business rule scenario of, as a new user, I can actually create an event and view it, that's the kind of setup that we would have for it. So you can imagine in a SaaS product that offers multiple features and editing capabilities and historical views, things like that, the number of functional tests you would have testing scenarios. In my mind, those functional tests are your ultimate goal, because they are the ones that give you the most confidence in your platform. The downside is, as you saw with that actual run, that's pretty small and quick. Imagine running thousands of those. I think our functional test suite is about 4 hours from start to end, which is not quick by all means, but it is a lot quicker than manually testing. So you work around that time frame by considering automating, just scheduling those tests to just continuously run and then tell you if something failed. And that way you can look at it and go, yeah, I'm working on that page right now, or actually that is a regression, we should fix that. Where's my slides? Come back. Cool.
Run that 4-hour test.
Ideally, constantly. Every 4 hours, run, finish, start again. And just keep looping around, because in that 4-hour time frame, depending on how your environment is set up, in the case of JESI, as we're pushing code, if we push that up on our feature branch, our CI and CD flow will automatically merge that into a development stable branch and deploy to staging. Now, I'll touch on that towards the end. Yes. But basically, as a summary for that we push new feature automatically goes into a staging environment for us to play around with. So an environment just for the JESI team. Our functional tests are run against that staging environment's code base. So in 4 hours, a lot of code can be written. So every 4 hours, it pulls it down, runs a test, and tells us this page is now broken, which allows us to go, I'm actually actively working on that page, so I know that's broken, I can fix it, or I didn't think that would break, and I need to fix that before we do a deploy. But I'll touch a little bit on CI and CD later on.
And Alex, can you tell us how that happened in terms of the browser and what tools do in that?
Yep, so that's what this slide here is. So this is using Fluent Lenium, which is a Fluent Java wrapper on top of Selenium, which is a very popular browser automation suite. So when I'm actually running the browser, in this case Chrome, it'll actually tell you that the browser is under automation. There's just a heads up going, you probably shouldn't interact with it, or maybe someone's got your system and is doing things for you. The way it interacts with the browser is Selenium, or Fluent Lenium in this case, will create that browser session. It'll hook into it and it'll go, start on this page. In this case, this is that page URL annotation towards the top here. So just go to the login page. We then actually perform certain actions, which are, as you can see, they're highlighted, like literally just click the sign up button. You know, wait for this form to exist, type in these fields, click this button, wait for this next thing. So it's pretty much a lot of typing, clicking, waiting. Your final assertions on that are either, I made it to this form and I can see it, or, hey, I'm on this particular page and I can extract bits of information based on CSS selectors or XPath selectors to verify that what I should see is actually there.
Is that what the purple click sign up button, is that a CSS ID or something?
Yep, so there's an example of that which is a little bit hidden above. So there's a login form here, which is just targeted by a CSS selector. Yep, so you kind of set all of those up so your pages have elements that you can target. So elements that are unique to that page that you can easily access. Sometimes that's a little bit tricky, which is where you might leverage XPath to specifically target by text value or something like that. And then once you have access to that element, you can interact with it however a user would interact with it. Now, some of these tests can be very complex. Sometimes you might actually want to execute code on the browser to verify things. It ultimately comes down to what scenario you're trying to replicate and what level of confidence you're happy with. So where we have some GPS capabilities, our functional tests don't actually do GPS testing because it's very difficult to set up and actually pretend you're in different environments in a browser during functional tests. So that's where we would rely on mocking in our actual code base to provide that coverage for us. Cool. So are there other forms of testing? Can anyone think of anything else that I may not have covered? Probably not, because you're all here to learn about testing.
I build games. What's beta testing?
Oh, so beta testing is typically where you will develop software, you'll get it to a stable point where you're wanting to test how users interact with it, get them feedback. So you'll release that software in a beta environment where the users will typically know there are potential bugs, there's something new that you're working on that you want feedback before you release it to a wider audience. Those users are usually trusted or compensated for their time testing that software, or are under the understanding that it is beta, and if it crashes, let us know, but it's not the end of the world. The biggest platform I know of this at the moment is Steam Early Access. Biggest platform. You actually pay to be a tester in that environment. Yeah. Yes, Kate?
I'm not sure if it's considered another form of testing, but not testing for success, testing for failure. So this is something I've seen a lot in API testing, so knowing your different responses from REST APIs for different types of failure, and do they match the failure you're expecting? And also when you're writing your code, expecting that there is going to be a failure and it can be handled. So we're not just saying, okay, we put in 2 and 2 and we got 4 and that's awesome. Like, as you were saying before, if you put in something ridiculous like null and 2, what comes out?
Exactly. And that is part of your actual business rules and your typical server design. So to kind of reiterate there, if I was posting a user login and I forgot a password, what should the server do? It shouldn't log them in. So it'll send a different status code. It'll send a validation message. Maybe I have a schema protecting my endpoint that'll tell me explicitly the password is missing. You will actually have tests for those in your environment as well that verifies those scenarios are working. If a third-party provider has all of a sudden thrown an exception, what do? We need to verify or at least make sure that we can handle that scenario. Maybe we retry that service. Maybe we just give up and tell the user, sorry, nothing we can do. All of that depends on how your system's written and what you're testing for, but yes, any edge case, any exception, any error your system should throw, any data validation formats, authentication or authorization, all of that should be tested.
Do you, like, in terms of things like security,
Mm-hmm.
say network security, are those sorts of tests incorporated with all the other tests, or do you separate tests in, like, depending on what it's trying to do, or is it something that everything's just integrated together and you're testing security
Excellent question there.
at the same time as you're doing it, efficiency and that kind of stuff?
Yep, so that's your security and penetration testing. That really depends on your knowledge and understanding of infrastructure, networking, how an application could be written, and you're really trying to assume like a black hat role, someone's trying to get into your system. Those tests you don't usually have with your separate projects. Unless you know there's a general security vulnerability that you want to make sure is fixed in, say, a library you're using, then you'll have a test for that. But in terms of networking, that comes down to your DevOps team. And your DevOps might hire someone who is skilled in penetration testing to go, we're hiring you to hit our system, discover what you can. Like, find out what you can, and usually that's a confidential kind of document where they will give you suggestions that kind of outline things that are weak in your system, or your system is good, or it's lacking here, or you need to move away from this, and then you should pretty much heed their advice. If you are rolling your own infrastructure and manually provisioning your own setup, then you might have network testing on top of that. If you're using a cloud provider like AWS or Azure or Red Hat, a lot of those setup, you can kind of assume that they've done the best job they can to the best industry practices. So you basically lock down as much as you can with what they provide and limit the amount of access you have into your own cloud. Yep. Cool. Yes? Load testing for performance and how many concurrent users you can have. That's not something you would typically do per project, but you would do on a functional test style environment. So you could spin up an API test, have many different machines, even if you wanted to provision cloud machines, to just run a script to just log into your site. Maybe you want to perform certain requests and just see how many concurrent loads you can have. That's not something you would run kind of constantly or per deploy, because
would you make automated tests to do something like that?
Yep.
On occasion?
So there are a few tools that I've used. Locust as the Python tool is one that I used a little while ago. They can be really useful on your own machine to just spin up, say, a Node.js server and be like, how performant actually is it on my machine? I'm going to fire 1,000 concurrent requests at it and just keep them hitting it to see how they respond. And that'll give you balances of average, timeout, and it'll ramp up to be like, this is your maximum. But unfortunately, all of that is really hardware-based. The benefit you can get from that kind of load testing is when you're at the extremities, you can force your application to scale up in, say, a staging environment to see that, yes, it will scale as load comes out. So that'll help that infrastructure test. But it can also help see what happens in your limitations. So knowing that is good for your platform as well. Other examples of tests, because there is just too many out there. You could have multiple platform testing. So that's where you'll be testing multiple environments for the same scenarios. In the case of a browser, that is, does Firefox behave like Internet Explorer? It doesn't. And Chrome. You could do visual testing, which is actually the act of taking a screenshot or an image of your application at one point in time and saving that, and then using that as a comparison for future releases to detect this button has changed color, or this button has moved, or this no longer looks like it should. That's very much requires manual intervention later when those tests fail to go actually accept this new image or no, reject this from going into production. You would have migration testing, which is all around the data in your database. Like all things, your data that you store and collect and how it's persisted in terms of relations, normalized, not normalized, all of that grows as your system grows. So we need a way to make sure that any data that was created from basically the beginning of your system is still read, is still accessed, and doesn't break any kind of schema rules that you have later on. As I mentioned, we've got penetration and vulnerability testing. I usually hope that those would be outsourced and usually require a lot of paperwork before they're even conducted. But you definitely do want to do those as a massive SaaS provider because you don't want the black hat to get there first. Chaos testing, this is something that Netflix really loves. They will actually intentionally tear down one of their servers in production. They'll just be like, this service no longer exists, just to see how their system handles it. Does it recover? Does it fall over? What do they need to do to make sure it? Will it seamlessly transition so the user's unaffected? That is an extreme level of testing, but I can see why they would do it. As we mentioned, system load and stress, so that's how many connections. You also have availability testing. Okay? Is your site available in, say, the US if you're global? How performant is that connection to you? Like, are they waiting seconds before your site loads, or does it feel like it's a closer system to them? You also then have translation testing, which is making sure that strings that you may read in your language of, say, English, actually read and translate coherently to another language for a user if they're doing that, or if they're trying to read that. Okay. Come on in. Sure. So as Lindsay mentioned with the what, as acronyms are thrown around of CI and CD, CI is continuous integration, CD is continuous deployment. So this is something that we have kind of transitioned to with the cloud-based infrastructure. Continuous integration is the act of having all of those tests and different kind of scenarios and setups I've described before run continuously, but not on our machines. So we actually pay someone else to run our code and tell us that the tests are passing. We can then use that particular provider to do other automation tasks, which include deployment of our product, if we so wish, when the tests have passed, and that's your continuous deployment step. So in terms of the JESI product, this is an example of our actual workflow. So the first two columns there is actually the continuous integration we do. And as you can see, we've got tests for coverage, integration. We can verify that our application actually runs. We have migration tests. And we actually have another run test to verify that it can run inside Docker. So just a couple of different little test suites we do, and there's actually more coming. But Circle CI, in our case, every time we push code up, will run at least that initial test suite. Now, assuming those test suites pass, and depending on what branch this continuous integration tool is using, it'll perform extra actions after that. So if it's our feature branch, that's where it'll automatically put it into staging for us. If it's in the case of our master branch, this is where we'll actually do a backup of our production data, because once again, you don't know what's going to go wrong. So if our server deletes data, we need to be able to quickly restore that. So having a latest snapshot before deploy is very recommended. We'll actually build our code, we'll deploy it, and we'll deploy our other server in this case. So as long as you have enough testing, enough confidence, all of your bases covered, your continuous integration is a simple automation on top of your manual processes as a developer that scale to many developers in a team. And the deployment is basically a fire and forget mechanism. So we can just go, yeah, we're going to deploy this, and we carry on with our work, knowing in the back of our mind that our tests are going to pass. Our automated test runner here is going to tell us if they fail, and if it does pass, it's going to go out into production. Whether we're happy for going into production depends on how much testing we did before that branch. Giving me PTSD. Server's going to crash. Are there any questions around CI/CD? Yes, Kate.
Do you have any automated sanity testing after go live with stuff in production?
We don't have testing after go live, but we have a lot of alarms and monitors in production that pretty much tells us if something goes wrong, we know before the user is able to actually report it to us, regardless of the time of day. So if our server throws an error, everyone on the dev team at JESI will get an email and a Discord notification and potentially a Slack notification to basically, this thing has happened. So that's when it's on us in our stress levels to analyze that error and go, that's either related to something we just pushed and we need to fix it quickly, or the user's using our system in a very unique way, and we don't have to address it right now, but we do in the future. So in our system, whenever an error occurs, whenever a bug occurs, that is more critical than, say, potentially the next feature, because users are using that right now, and if they can't do that, that's a degraded experience which takes money from our pocket. Yep.
I'm just wondering, Alex, and
Yes.
maybe I'm not looking at this thing, maybe I just haven't found it in there, but do you have any mechanisms in place, say, because I imagine something like that is going to be generating a fair few logs. Do you have things that you do for like log analysis to like test whether your integration system is getting more efficient or whether there's areas that you could actually tidy it up and things like that, like number of tests?
That's an excellent question. These particular test runs here as an overview don't tell us that. They will tell us if the test failed. Any one of the tests in the scenario failed. Your code coverage will tell you things like, this is your slowest test, this is tested too much, or you have a lot of coverage here but not much here. So those are third-party analysis tools that depend on the language that you're using. We don't really have log analysis for our tests because it's business scenarios that we've generated that you'll get the same result out every time you parse it. But we can introduce log analysis in our production environment and logs through there because we have all of our logs from the beginning of time. Yep. So if we really want to analyze that in the future, we'll shift through that. But in the case of Circle CI here and many other new test providers or test automation systems, they will offer some additional insights for you. So in this workflow here, if I was to drill down into each job, Circle CI would actually automatically pull out going, we spend a lot of time just waiting here. You know, maybe if we bump up our box, that'll be quicker. Maybe if we separate this out, that'll be quicker. And it's really a case of, in CI and CD, trial and error. You know, what is more efficient for you? So what we found out here was rather than every single test job fetching dependencies, we do that as a separate step that might take 30 seconds first. And then all the other jobs branch off that. Which is fine in this case because those dependencies are cached. If we introduce a new one, dependencies could take 20 minutes to download, depending how many there actually are. So that saves a lot of time per test case going through. But like everything, you've got to analyze it as you set it up and basically make it as bulletproof as you can. But being a third-party service, you may have an API you can interact with, but usually you're just dealing with their UI and environment and how you can make it adapt to your needs. Yep. Yes, Lindsay? Yep, so in this particular scenario, Circle CI runs everything inside Docker containers, which is why we have a specific, can we run our environment in Docker? All of these are isolated, essentially virtual machines, so we know we're not sharing code with another system. They can't access our stuff. That's part of the promise that we have. And yes, they're all in virtual machines in that regard. But when we run the tests on our machine, in the case of just the general server tests or front-end tests, they're all just on our hardware, as is, no virtualization. Our functional tests, however, in JESI are all Docker containers composed together to simulate networking environments and connections. Yep. Yes?
When you've got a new feature, how do you know you've got a test in there for it?
That comes down to your development process. So in our case at JESI, I might work on a feature. I, as a single developer, cannot push my own code into production. I have no permission to do so. I can push my code up for review, but ultimately another developer has to review what I've written before we can merge that in production. So that's a safeguard that we have in place, and it's a safeguard that most other companies will have as well. So that gives you multiple eyes on the feature. Now, depending on how big that implementation is, will depend on how many other developers will review it and how long that review process will take. So kind of put in context here where we just developed a whole new page that replaces a previous one. Development time was maybe 3 months from start to finish, on and off. I think it's maybe 18,000 lines of new code approximately. So with just me writing that, I can't even remember what I've written. So as part of our process, we've had the other two developers. Yeah. Had the other two developers come in, review every single line. That's taken them multiple days and come back, come forward. They've suggested comments, changes, things that I've overlooked, things that I potentially need extra tests on. And then I go back, redo it, and they re-review. And they might re-review just my changes, or they'll re-review the entire thing. So that really comes down to your quality process. Once it's pushed into GitHub and merged into master, deploy away. Yep. Any other questions? No? Excellent. So I have a few questions. What do we test first? Data access layer, API, end-to-end, functional. So from all of those kind of things I pieced together before, where would you probably consider start testing? Yes? Functional testing could be very difficult to start with. So we got browser automation, but if you're starting a new project, you don't have a server or a front end, so the functional test doesn't help. If you are tracking down a bug, absolutely functional test. If you can reproduce what the user is doing and verify that, you can write a functional test to reproduce it, run through it, go, yes, it's broken, which it means that it's there so that when you fix it, you can run it through, test pass. So maybe not when you're starting a project, but absolutely if the project's existing and there's a bug, yep. What, sorry?
Data access layer?
If you're starting a project from scratch, you might consider starting at the lower levels, in which case, yes, you'll build some layers up there. Likewise, if you're switching or transitioning to support JSON requests and XML, but you don't have XML originally, then you'd start an API test. Start that at the top. If you're developing a whole new feature and you're starting on the server, start an API end test. Assuming everything else is already set up, just go, this is the data I'm expecting, and then work your way down in implementation. What I'm getting at here ultimately is it depends on what your scenario you're testing. You might start low layer, you might start upper layer. It really just depends what your system is, what you're implementing, and how you can do it. As long as you have tests. Something I was asked to include is what's better, test-driven development or behavioral-driven development? Now, does everyone know what those are? A little bit, not really.
Explain.
In the TDD, we test the product with different test cases, and the behavior, we analyze the behavior of the particular product, how it's behaving in that scenario, in that particular environment.
Yeah, so as mentioned there, TDD is a methodology of testing your product. And it's called test-driven development because you are meant to write your tests first. So whatever layer you're actually talking about or whatever you're trying to do, you'll write the test case first to make sure that it's hitting your, what it should be potentially hitting, maybe not implemented yet, but with the right data and asserting what you want it to come out with. You'll then work through and actually develop the test case and make it work, make it pass. You'll then do your next test case, whether it be your business rules or edge case. The test will fail. So then you'll rework that little bit that you've already written so both those tests pass. You'll then do the third test and keep that cycle going. Behavior-driven development is the kind of opposite of that. You start with a scenario that has multiple steps to it. And behavioral-driven development is really good for your business cases because it acts as that documentation. In the case of the JESI platform, as a traveler, I am able to create a journey that has at least 2 checkpoints and is in the future. So there's multiple things to test in that scenario, but the behavioral-driven development allows me to set up initial things so that one bit passes first before the next bit of validation, before the next bit of validation, so they continue on to build your one test case. Ultimately, in my mind, there's no better scenario. There's no, none of them are better than the other. I will actually use both. I'll do behavior-driven development myself for the actual API requests so that it explains the scenario straight up to the user. And I'll do test-driven development for lower layers. I just go, I know I have this data, I want this result, make sure it gives it to me. So you'll actually mix and match. Once again, as long as you have tests. Something else that I get asked a little bit is, what is my personal and JESI's, other JESI developers' development cycle? This, in context, is how do we write a feature? What do we do? Ultimately, we do one of two things. We'll either build the feature, we'll then do the testing, and then we'll do a refactor, or we'll do tests first, build the feature, and then do a refactor. Always refactor last, which is the process of cleaning up your code, making reusable, removing anything that was just put in there for testing purposes or development purposes. But the first 2 steps of testing, development, or development testing, for me really comes down to what I'm implementing again. If I'm designing a whole new page, I'll actually build that page first. I'll try and gather what information I need to render on that page before I start on the server with tests. So I'll actually have the server give me results and then I'll refine it with what I actually need. If I'm actually just doing server changes and not even considering the front end, then I'll start with tests first, going, here's a whole bunch of my data. Now, what result are you going to give me? as long as you have that testing again, and as long as you do the refactor towards the end to clean up your code, it doesn't matter. Ultimately, when you push it in production, the tests are there, the code's there, it's the same cycle. Cool. So we have Andre who's...
Cooking.
Andre's cooking?
Yep.
Really?
Alex, are you still taking questions?
Yeah, I can take questions. I just need Andre's attention. There we go. Yeah.
Just validating your test. So, you know, with the trivial test that you showed us about adding.
Yes.
If you'd used 2 and 2 and asserted that the result was 4, but it actually left times right,
Mm-hmm.
it would have shown you that it worked, but it didn't.
Correct.
For other test data. So how do you know that your test fails when it should fail?
Yep. So when you're building your tests, it's one thing to go, they're failing, they're failing, they're failing, they pass. It's a happy feeling. You get a little bit of an endorphin hit. But what you really want to do there is go, it passed. So if I modify my test data, will my test now fail? And if I modify it back, will it pass? Exactly. So you're testing your test, which is testing your assumptions again. That's something that you will do when you start kind of with unit testing. You'll get more and more familiar with it. As you get further on, it'll come down to your experience. So if I'm doing an API test and the server goes, here's 200, great. You know, as long as that permission is there and I have another test that's testing the other permission, then I'll have confidence that together they've matched both scenarios. But it's very simple and a quick thing to break your test and then fix it again to make sure it's doing what it should.
So do you have any, like other than just you know this, you do this, do you have any actual like structures in place or sort of documentation about when you write tests that should, how you do it, or how many cases you would have, or always test boundary conditions, that sort of thing?
Really comes down to the team you're working on. In the case of JESI, there's no real documentation around that. It is just what are the business rules, and if you're a new person coming into our team, a new developer, we will instruct you with the experience of these are the scenarios we want you to test, and then here's some extras. You know, lower layer down, if you're just giving one input and getting one output kind of back, you might rely on the type safety of, say, Java. You know, you can only give me UIDs. So ultimately, you can only give me UIDs or a null. You can't really give me an integer, it won't let you compile. So you can rely on that a little bit. If you're in JavaScript land, you could give it anything. So that's where you might test other scenarios and conditions. Yep. But once again, in the first principles, you try and test as many edge cases as you can and aim for that 100%. This is what can happen in my business scenario. So what output should I expect? Yep. Cool. So I'm going to hand over to Andre here for a bit, for the last couple of slides before we have dinner.
Yeah.
And I'm going to give you the microphone.
Oh, you give me the mic? Yeah. Okay, can you hold the other end?
I can. Okay.
Actually, I'm just going to hold that. Yeah, so awesome to see everyone here. Thank you so much for coming to tonight's event. A little bit of what we want to do tonight as well is advertise Dev Club. So this really is an opportunity for you guys to come along and work together on projects, an opportunity to, I guess, you know, learn from industry, learn from professionals, but also for you to sort of try out some cool things and things you wouldn't normally do. So you might have heard about a new language or library or sort of thing. So, well, come try it out at Dev Club. Give it a go. It's a great way to really practice collaboration. So how do we do things in the real world actually? Working as part of a bigger team, how should you do things? Dev Club's a great opportunity to come and give that a go. You can also build up those skills. So, I'm not too familiar with, you know, the command line, or I'm not too familiar with Git or the best way of doing that. Come along to Dev Club. It's a great opportunity there to learn those things as well. And, you know, you get to learn from professionals, people that get paid to do this and who sometimes question their life choices, but at least you can come along and learn from them as well. We'll also help you with some of the projects, and that's really what I wanted to do tonight is, you know, there's some of the projects work, but want your project to come along. So we've built things like Rudolph, where it was a Christmas light finder. So where are the cool Christmas lights in Townsville? Hey, there's an app for that we built in Dev Club. We want to organize the scores for a shooting competition. Centerball, thing that Alex built. I want to do a thing where I can build different projects as a service. Let's do that. If you want to build Discord bots, if you want to build libraries, you know, we want your project there. So those professionals at these events will also be there to help you facilitate, give some advice, and join in. So, but really we want you guys to come along and get involved in Dev Club. I think it's a great opportunity to learn and get excited about some of the cool things that we can do in tech. But I think next, did they answer all the questions?
Yeah.
They got it right? Yeah. Okay, you're allowed to eat. So certainly we're going to go outside there. We've got some sausages and some salad. Please do continue the discussion. Have a chat with those people you haven't met before and with some of us professional people. But finally, let's give a thanks to Alex for his talk here. So. Yeah, cool.
That's about it. Did you have anything you want to add, Tristan, at all? No other events that we have upcoming? No call for speakers? Nothing?
Okay. There is an event that Safety Culture is holding tomorrow. It's up on the Facebook page, but the chief entrepreneur is in town, and she is visiting Safety Culture for a visit, and Safety Culture have invited along any members of DevNQ that want to go along, meet the chief entrepreneur, have a fireside chat. For those of you that don't know what a fireside chat is, it's just a kind of sit down where there's someone who talks to the person who's being interviewed, but it's kind of a casual thing where they'll ask some questions and ask the audience for questions and stimulate conversation that is interesting to the audience and the people in the room. So if you want to come along to that, RSVP on Facebook. I'm giving numbers to Safety Culture for catering tomorrow morning, so preferably tonight if you can. But that's a great opportunity to meet the chief entrepreneur. She started a number of successful businesses, including some most recently using the blockchain. And she's up here to kind of find out what's happening in North Queensland and see what the state government can do to help the businesses and the individuals up here build new and better businesses to help the Queensland economy. So it'll be worth it if you can get along. That's at 4 p.m. at Safety Culture in the city tomorrow. Safety Culture is on Sturt Street, but all the details are in the Facebook event if you need them. So, thank you. 4 p.m. Thank you, Alex.
All right.